Okay, hi guys, and we have Donna. Hi Donna.
Hello, nice to meet you all.
Welcome.
Sorry I'm late to the party.
Yeah, not late. So can you introduce yourself?
Hi, I'm Donna Lehr. I'm with One Up Health. I'm also a registered nurse by trade, so I have some subject matter background. I've supported data governance here at One Up Health, and I've been a subject matter expert for a lot of the FHIR requirements as they relate to claims and things like that, and do a lot with our current SQL on FHIR product as well. So I am joining the group to see what everybody's up to here.
Great, welcome.
Let's start, guys. So I think we have the discussion of the next Connectathon, yes, to decide what we gonna do on Connectathon. So Ryan, hope you will be able to join us.
Yeah, is there? So I'm gonna try. I have a personal constraint over the weekend that I'm trying to work around. So the verdict's still out, but I need to make some arrangements. So we'll see if I can make it. I'm hopeful that I'll be able to make it at least for a good chunk of it. Nikolai, are you able to attend, Nikolai?
Yes, I'm going.
I think I'll probably be able to swing it. Yeah, it's like when your spouse and you both have work travel that overlaps, and childcare arrangement gets in the way sometimes. So those sorts of logistics, but I think we can work it out.
Brian promised us some discussion and demo about standard SQL.
I have something, it's not quite that. So I went down this path of, and maybe you all know, I tried to find the most ANSI SQL engine I could find, and I've been long trying to work with Trino, which is the open source version of Athena, I think, on AWS. And when I started to try
originally Presto, yes, so it was called
Presto.
Yeah,
they renamed it for some reason. I don't know that community that well, so I don't know what that was. And so as I started to try to do that, I started to create some schemas and things, and I went back to our original topics before. Is Dan on? So it's the Dan Gottlieb multiple level approach to SQL on FHIR. And let me share my screen here. I can show you what I was looking at, because I needed to have a model to represent the schema of. And so I kind of went back to using logical models. So here's a regular CQL, a regular FHIR condition that I've modeled as SQL condition. And the approach I started to take was like right here. So you can see kind of at the root of the resource, I'm experimenting with this idea, like this flattening idea, as such, because I wanted to be able to have a schema so I could try to do joins and queries and stuff. I'm not sure how you all, I think to date, the thing that Nikolai did and others seem to be more about querying within a single resource. And for some reason in my mind, immediately when I think of SQL, like SQL is how you join tables and how you join things together. And so that's why I keep coming back to how can we do the Dan Gottlieb layer 0? Is there a way we can start to agree on how things might get flattened? And so this is the approach I took. I'm not sure if this is at all what anyone else was thinking, but I started to do this, and then I started to say, okay, well, how am I going to actually create an SQL schema of this following ANSI as best that I could? And I just discovered, obviously, to a lot of you probably already, is that there's some primitive data types in FHIR. And I went through this exercise of how would the primitives in FHIR map to ANSI primitives. And so I went through the primitive list from the FHIR website and took a first pass at what I might, and I'm probably wrong in some of these, but I tried to kind of decide, okay, what is the ANSI equivalent of all these? Because I feel like this is important to figure out. And so I did this exercise, and then back to, okay, now I have a way where I can start converting or start building out what a SQL condition might be. I have these flattened things, I have my data types, and when I started then to look at a resource that had a slightly more complicated reference, so I think the level 0 was like, how do we take references like subject, actually where is the subject? I might have screwed this up. I don't actually see the subject anymore. Anyway, there is a reference to encounter and subject. I don't, oh, here's subject. And so how do you flatten subject out? And so I said, okay, maybe there's an ID and a type because a subject can be patient or group. And then for the abatement and onset periods, we talked about flattening those out to, I guess, appear like always have a start end, kind of normalize that. And then I started to look at encounters, and I decided that encounters might be a little trickier because what I tried to represent an encounter was, okay, we have this nested participant that has actually, you can have many participants in an encounter, and if we wanted to kind of flatten out the references to the individuals, how would we do that? Also, we have a type concept. And so I came up with a few things. This gets tricky. So subject's the same, but when we have this, I was thinking maybe we have it flattened out because it's multiple. We don't have, we have pairs, or in this case, I guess, triples of like what they represent. And so I played with ideas like, would this get flattened out into like field that's combined maybe? And then this one, as an example where the participant actually has a type. In this case, there's a code that means they're the primary participant in the encounter. That's unfortunately how far I got. So I'm starting to try and flatten these things out ahead of trying to build schemas. And I am kind of going down the path of trying it out in Trino, but I didn't quite make it to actually demoing it, but I did want to share at least some of the thought work I put into it thus far.
Welcome to the rabbit hole.
Yeah, so I'm not sure if you all already figured this out, but I found it interesting.
Brian, I did share an example of queries with a quality use case in the general channel, and that's actually Presto as well. When I query in SQL on FHIR to flatten things out, I've been using the cross join on nest. It's a pretty powerful feature. So take a look at that example if you're digging into Trino.
What does the general channel mean?
It's in the GitHub page here. I'll put the link.
Oh,
Discussions, a couple
oh,
top,
okay.
top
I
discussions.
was looking in Zoom. Let me see.
Here,
I asked Donna what technology. So you said it is Presto on top of Parquet, or?
So we've got our FHIR server, and then we take it. I think there's some kinesis factors before it goes through Databricks, and it's NDJSON Parquet for the analytic platform. So we're basically just querying that. Your table schemas are your standard FHIR resources. So just like I would do an API call to the explanation of benefit table, the table schema is the same, FHIR_R4_ explanation of benefit.
Do you do any transformation to resources when you convert it to Parquet? I mean, do you parse references?
Each column, so similar to like a FHIR server, you have one resource per individual unique ID. So in your Parquet table, you have one row for each FHIR resource. And then the columns in your table are like the starting path of each path in that FHIR resource. So we'd hope for a future like where this could even be cloud agnostic of a product for us, where you can just deploy it on any platform and then it pulls in, right? Because FHIR is a standard, and if you're pulling in just the paths that are in each resource, then you're querying like I want to query supporting info in the explanation of benefit. The array is within that block, and then I would unnest the array from there.
Yeah, I see your example. I guess I heard that this splitting, like I think Dan brought it up. He was concerned that if in the standard approach for this at runtime, at query time, we wouldn't want to be splitting strings and stuff. And that was kind of we talked about before, flattening all that out, and then the same with these choice types around dates. Like it could be any of these dates, but we would always have a period with a start and end. Like there'd be a schema we would target. But yeah, I see what you did here. This is nice. So thanks for sharing that.
Right. Right. And the reason to also tune into this example, if the folks, that are exploring this, if you've been used to, working on like quality measurement and use cases from just a provider community, like the data that's in their EHRs, right? These queries give you a better understanding of that payer administrative data. So when I'm going into patient and coverage, things like that you would look for, that you might not have that complexity running measures just for the provider EHRs and the ECQMs.
Mm-hmm. Then you have a quick question.
Yeah, sorry. Also, I've been on. I realized that it had logged me in as you again, Nikolai. And there must be something with the link in my invite where it
Yeah, we all have that problem.
That's how
Okay.
Zoom force you to log in.
Got it. Okay. Anyway, I just caught that I was actually not listed as me. So yeah, this has been a really good discussion, and thanks, Donna, for some real world examples. I feel like that's always a good way to start a conversation. I just wanted to clarify, since Brian brought up a comment I made earlier, which is like, I think one of the things that would be really good to figure out and put in the spec is if there are some kind of SQL transformations that we're making on every query. So things like if you have relative resource types as your references, like everybody is splitting those every time to be able to do a join. And so that seems one area where I found, at least, like those string operations, I guess I haven't tested this in a year or two, but we're really slow on BigQuery and Athena, and maybe faster now, but that was like the slowest thing in every query was kind of splitting up the strings and references. So that seems like an easy win in terms of kind of pre-splitting those, either on ETL basis on load or ELT just after load, but doing it in some way seems super valuable there. And then the other the other related one that Brian just brought up is on dates, which is another instance where because FHIR may have partial dates, and also you may have dates with some uncertainty in them, and also you have some dates that are ranges and some dates that are instance. Kind of treating every date as a range with a level of uncertainty was kind of helpful. And so that was another transformation that was slow to do on every query, and seemed like the sort of thing, since you almost always want that. You may decide that you don't want to use a particular date because of the level of uncertainty, but if you do want to use it, you probably want it be able to treat it as a range. So I guess like Brian was talking about kind of level 0, I kind of feel like there's probably this bucket of things that we want to do on every query, and those things could maybe be done, be defined as like an ETL step or ELT step that we would just kind of assume is done on all platforms for data that's going to be considered with SQL on FHIR. And then of course there's the higher level things, which is some of the things I think Brian was kind of alluding to around like restructuring data to make it easier to query. But I think to me, those are almost different levels. They're the things that just kind of you want to do every time because you're never going to not want to do them. And then there are the things that are good for some use cases, but maybe make other use cases more complex, or are things that work well on some platforms but don't work well on others. And so trying to make that distinction, I think, would be really valuable for the group.
Mm-hmm. Thank you, Dan. Ryan?
Dan basically made the comment I was about to make, so I switched it to a thumbs up and pass it to others.
Mm-hmm. So then you think that we only need couple transformation on our transformation layer, ID and dates.
I think there's some patterns. I feel like sometimes the references are arrays, and we have to figure out how you'd serialize that. To me, that's like another pretty core use case. And then occasionally, like in the participant references, there's even a concept of what type of participant. So I feel like at least I think there are places where you can have 0 to star references, and to how you would serialize that in SQL would be how you would flatten that might be something else.
Mhm.
Yeah, I feel like there are two layers to this. So one is like the set of transformations that would apply to basically almost every like sort of basic element. So date times might switch to ranges, like references might switch to like in a pull out the raw identifier so they can be efficiently adjoined. By the way, it's absolutely the case that string splitting in the SQL engine is going to eliminate a whole bunch of query optimization. So if we can pre-split that, to Dan's point, that very much would improve query performance, I think, in a lot of engines. So I think there's that layer where like dealing with like the low level elements, and then there's this higher layer, which I think which it was more reflected in Brian's example of creating like a flattened view of it, having a definition, a description of a flattened view which all the examples that Dan described applies, and there's things kind of are described in a much more tabular format. And I think that aligns with some of the use cases that the feedback that I've heard as well, in that. I mean, just to kind of use the SQL that Donna had shared to illustrate, that's an excellent pattern, an excellent use case. It's also a pretty demanding set of SQL that takes a pretty sophisticated SQL user to author. And so I know that there's a lot of folks that want to plug FHIR into analytic tools like more off the shelf, that are not comfortable with a cross join on nest, and in many cases like multiple bringing together cross join on nests. So I think that there's these sort of two complementary models, where a set of base transformations that Dan described, and then a set of a way to flatten things up into more columns. And yeah, and if we have time today, I can like I think we mentioned last time that we've been exploring some mechanism of using FHIR path as a way to describe the flattened columns that match like what Brian had shown in his schema, or very similar to it. So I can touch on that a bit later today, but I don't want to steal this discussion quite yet. So yeah, I'll pause there, and I think Josh had his hand up next.
Oh yeah, I just wanted to ask from the perspective of flattening arrays of references. Is that an important outcome? Like if the references themselves are broken into parts that make them easy to query or join against other sources, is it important that the array be flattened, or do we not want to assume that like array data is available to us as part of our model?
I don't know.
Yeah, I think that's a good open question, and maybe this kind of goes back to what sort of assumptions and requirements we need to make, and maybe we should kind of step back to that. I do feel, for what it's worth, I do think there's a use case that folks would just want to see just purely rectangular tables, and that's it. So everything would. So if you have basically a multiple set of participants, they might expand into columns where you have, your primary care provider is ID as a column, and and the other participants would be their own columns. That way it can drop directly into a bunch of analytic tools more cleanly. So I think that we should seriously consider a flattened model in which there are no arrays whatsoever, and be able to handle that use case. Now, I'm not saying that's the only way. That's obviously not the only way to do it. We can have these nested structure as well. But if we were to offer purely flattened models, it would open it up to a much broader audience and a much broader set of analytic tools. And I think that Brian's stuff was fairly close to that, because that looked fairly flat.
Yeah, I only can add that the FHIR could not be mapped to the like one-to-one to flattened view, so that we should consider flattened view in the second layer. So in the first layer, I think we still have arrays or collections, and we can use on nesting. And because like Brian, in some collection, you want index by different attributes. Yeah, if you want to index participants by type or something, or components by code, yes. And then a lot of questions arise how I would like to index. And sometimes you may do it one way or another way. So then probably the second layer of flattening, which will suit for some use cases, but it's not going to be one-to-one mapping. So that's my vision. And that's, I think, Josh, what you asked. Yes. So initially, yeah. So the more I think, the more I understand that probably we will do the minimal transformation, like IDs, dates, and maybe a few others, and then go to the flattened views, which are going to be use case specific.
Hey, Nikolai,
Yeah,
why can't you flatten? What's the specific reason you can't flatten in some cases?
Because there could be multiple ways to do this. Let's say you have component and observation, yes? And component is coded with a code, which is a codable concept, which may have multiple codings. And you definitely want to have, I don't know, systolic and diastolic, yes? But how it's coded, yes? It's array of codings. So there is no way to understand, they have simple algorithm, which will kind of create like systolic and diastolic attributes, yes? Now, if you can assume there is a lowing, you can do this by lowing, yes? But it's just assumption, yes? So it can be done, for example, for US core, yes? We can say, okay, that observation should be coded with lowing, so we can index this concept array by the lowing codes. Yes, just pick the first lowing code and index it. But that's not true for other use cases. Yes, I can imagine some observation without lowing or with SNOMED CT or something else. I even coded with the two codings from lowing because I don't know, it's something new for the lowing. That's why I think that, yeah, we will have kind of very, very simple FHIR with a few transformation, then do this flattening, but this flattening are gonna be use case specific. And as Dan suggested, it can be namespaced and somehow described with the logical models. And probably some assumption can be added to this view, like, yeah, if I, even like profiles, yes. If it's observation like US core observation, so you can apply this flattening. If not, okay, then you could not.
It's exactly what I wanted to mention. So basically, once we agree on the structure of the tables, like in some nested format, like in JSON, we can leverage some profiles to generate these flattened views, because in the profiles we have definition of slices, and if we have a slice, we can flatten some array, extract this value, and use it. Because basically, when we define slice in some array in FHIR resources, it means that we need this particular item with particular code. It could be very simple algorithm that take structure definition of profile and create a CQL that creates this flattened view. I think it's a very powerful approach.
Around the idea of flattening views out and having like, you know, you see OMOP on FHIR, you see a lot out there that are considering, you know, what standards are already there. And at first, you know, I thought that that was a good idea, even for making it more user-friendly for people to query that may not know how to unnest data and query arrays. But for the sake of progress to FHIR, and if you think about this from a mandate perspective, right? Every payer, large managed care plan in the industry had to convert all of their administrative databases and their clinical data that they maintain to FHIR back in July 21. So if we're saying that now we want to take it from their ANSI database and turn it into FHIR and a platform, and then downstream into an analytic platform, and then further turn it back into those OMOP structures that their inputs came from, you're going to get a domino effect, right? Of why do I have to do it down here? And why can't I just keep doing it up here? So I guess that was one consideration. And once I really started using those cross-join on nests and things, also think about, is there a limit to how many views you can have inside, especially if you're using a serverless database or an actual database? Like the spirit of FHIR is we want less data waste too. Like, so copying this data over again so many times, you know, it might not be necessary. I personally like it even with the nested data, because everyone in the community is trying to solve a different problem. So just flattening out observation might not help them. Having open source access to a code that unnests their data to a view for their business use case, and then they can just use the views off of that is, you know, another approach. So it's just something to think about, you know, as we are flattening all this out, to also think about the pushback that will happen if, you know, if we're saying it's better to compute from this part of FHIR, then why isn't it just as easy to compute upstream before it's FHIR, right? And I have an answer for that, but I don't want to take up all the time. So it's just
I'd
something
be
to
curious
think about.
I'd be
you're
curious
proud
to
of
hear
that,
your answer. Yes. Oh.
Just tell us.
Well,
Yeah.
my answer is the benefits of FHIR is the speed, the timeliness to access it. You know, patient access brought in mandates where you now have access to claims within a day of the adjudication decision, which is the point that the claim is processed. In your standard EDW warehouses, your claim isn't landing in those until after the payment cycle is complete. So your decision to pay and how much is going to be paid on a claim or a service is determined when it goes through the engine. That might happen a month or 45 days before the payment is actually made. So historically, we didn't have as fast of access to claims. And now we've also got clinical connectivity as providers are upgrading to US CDI. We have a more standard data exchange. So timeliness of access is a benefit, but we also want to be mindful of, you know, the downstream stuff with flattening it out and unnesting it without the business use cases. You know, everybody's got a different problem they're trying to solve that they want to use FHIR for. So.
Yeah, cool. Yeah, thanks for that perspective, Donna. That's yeah, I think that sort of aligns as nicely. And I just wanted to add one comment to the previous. So first of all, kind of the way I look at it, for folks who are comfortable using that deeply nested unstructured, I think that definitely makes sense to preserve that use case, because that's you know, as close to a lossless version of FHIR as we're going to get. Any flattened view is going to be sort of probably lossy in some way. And I was kind of thinking of it as rather than if we have like these descriptions of flattened FHIR, whether it's actually materialized or actually implemented as like a virtual view or even like a common table expression like what you have there. I think either one would be very workable. I know that a lot of users that we've seen are very interested in just working with just the flattened view. They don't really the purely tabular data model. But if that's just a view over the data rather than a separate ETL job that makes another copy of it, I think that's entirely workable. So yeah, maybe that's sort of closer to the pattern that you had as well.
Mm-hmm. That's exactly what I was thinking. Like I was going to say that, but you actually said it, and I'm glad I preemptively lowered my hand. But I was going to I just add that I would see, maybe I conflated layers 1 and 2 or 0 and 1, but I do see like these as building blocks. And so I think at some, and I really it resonated hearing the idea of like, we have these layers and you may implement any one of these layers, either with maybe some ETL process or maybe a materialized view or whatever. And it as long as you can do that, you can take advantage of the building blocks on top of it, sort of thing.
That is one thing that I don't think you can do in the serverless is the materialized views, but you can do the views. It may just depend on what's being used, but something to think about.
Yeah, I guess kind of related to that point, like I would add that I don't know that we need, like that's a decision we necessarily need to put in the spec. So I think one of the cool things about SQL is kind of the composability, so that you can take a select statement and it can be a CTE or a common table expression, or it could be a materialized view, or it could be a table, or it could be a view. And it's really kind of how you choose to, I guess this is particularly coming from a DBT perspective, but like applies kind of across the board with certainly with SQL macros, with lots of ways to kind of take your SQL and inject it into different places. And so if we can define, for example, well, depending on how we want to do this, if we want to define a way to create, to specify flattened views and a way to convert that into SQL, or if we want that to be SQL directly that converts between engines, different users can decide if they want that to be a pure view or if they want that to be materialized as part of an ETL process, put into a schema that's restricted for specific users. So sorry, this is maybe not the most coherent thought. I'm having a little brain fog, but I think the kind of the core idea, I think, is that if we can define the transformations from FHIR to SQL, like how that gets represented in an actual SQL data warehouse, can still be kind of up to the user rather than defined in the spec.
Thanks. And I think, Ryan, so you prepared the demo for FHIR, yes? So
yeah, so I can I can show this fairly quickly. So basically the context here is like we've been exploring ways of creating these flattened views in a way that can be unambiguous and portable between systems. I think it very much aligns with the approach that I think Dan and others on this conversation have brought up in terms of we have the SQL on FHIR. I mean the full FHIR resource and with all the nested cross-join glory as the basis. We create views on top of that, and then we can query those views to make it really easy to use. We've been exploring using FHIR path as a way to define the columns. So basically, every column in the view would have a FHIR path expression, and then translating that FHIR path to SQL. So we have a working system up that does this. I can kind of show it in action for those curious. Okay, so I'm just going to kind of show this. Actually, maybe I will start with a little bit of background here. So I'll just kind of go through these quickly to kind of show the approach. Kind of making a few assumptions that I think that we discussed earlier today. So I'll just go through these. Well, maybe I won't talk through each one of these, but essentially this level 0 and level 1 pattern that we discussed of the big SQL on FHIR underneath and then simple views on top. And how can we do that? So since we kind of talked about that, and then some patterns there. Actually, since we don't have a lot of time, I'll just kind of show like the patterns that we're been exploring and then the working code that actually does some of this. So let's say just starting like with a really simple example, if we wanted to create a table of home addresses, if we could have like some definition. Now this is just completely sort of a placeholder example that's very simplified. If I could imagine this actually being a resource, in which case we'd structure it a bit differently. But you can see if I want an example of patient home addresses, this would basically be an unambiguous description of kind of getting that, where you can kind of see the address and where the type and get the first one, get that sort of thing. So this would be a portable definition, and we actually have this going and can translate it to SQL. Just kind of illustrate the sorts of things that we're doing with FHIR path. Of course, there's a bunch of variations that we could explore with this. You notice like the expressions, there's a lot of redundancy. I mean, to find the home address, you see the same expression being run again and again. So it might be worth, since this is just total open exploration at this point, maybe we can factor that out. And if we have like some variables where we define the home address as a FHIR path expression and then kind of use that in there. Yeah, and so it would require addition of physical address to the cat. Yeah, fair enough. And yeah, we can definitely add anything you can express in FHIR path. So I think we could also check the constraint that Donna mentioned in the chat as well. Just not something I did in the simplified example. But yeah, but I think honestly that's like kind of all the more reason to create these flattened views of it, so we could have like one definition of home address, so the next person that needs the home address doesn't have to remember to check all the constraints. They have a view of home addresses that does that for them and kind of encapsulates for them. So in this case, exact same thing, just kind of putting some common pieces in this case. So this is like the simplest example. I think it does illustrate some needs that were going to be very, very common in any flattened view of FHIR data. And that is basically some sort of check on the content. So in this case, to get a home address, we have to check the address type and home. And then to Donna's point, we also have to check the condition for physical as well. So I think that any sort of view description we would need to have that capability. FHIR path does it nicely. So it's one of the reasons why I found that appealing. The other thing that, depending on how far we want to go in this case, is what sort of terminologies, if any, that we want to include in this. So for example, if we want to create a table of, in this case, I picked a very simple one, like LDL values. But pick any observation type that you're looking for. We can kind of, if we want a simple table of like the subject there and that sort of thing. There is like, and I'll touch on this, there's one case where I found FHIR path didn't map super well to this, and there's probably others as well, like getting that, but it goes back to that raw transformation that as Dan mentioned, is like getting the raw subject ID rather than a string. So kind of we added this sort of capability there. Otherwise, everything here is just pure FHIR path. And then each column there. Then for the constraints, we basically just are searching for the observation code, you know, a member of some value set. And so we can create this nice little flattened view of that data that can be queried directly. So yeah, so maybe with that, I can kind of jump over. So here's what we have going. And actually, while I bring this up, it's worth mentioning that this pattern that we've seen here, so we have a sort of an early implementation of it. The code is kind of a mess. We're kind of refactoring it from some internal research. So that's still being cleaned up. There's also this same approach was actually taken by the Pathling project. So John Grimes and company are also translating FHIR path to SQL. So there's a fair amount of evidence that this is workable, although it does come with some complexity that we can touch on in a bit as well. So I'll share this example. And to make this a bit simpler, we actually built like a simple sort of Python interface to it to make it easier to define views. So if I skip to this one, so this is just Python code here. And essentially what it does is it just kind of builds FHIR path expressions. And then you can actually see the FHIR path it produces down here. It's kind of convenient. This is, so I would imagine that a lot of users could just write FHIR path expressions directly. This is kind of like more targeted towards like a Python user audience, because the nice thing about being in that world is that you can get sort of nice tab completion, so you can see everything in this space. So if you're trying to actually author an expression in order to create a simple view, you can actually get the nice tab completion. So and the same thing applies for like dealing with nested address things. So if I have the current address, yeah, I can see like both FHIR path functions that I can run on that, and then the actual fields themselves. So anyway, so there's that, and then yeah, so that basically generates this SQL and then produces this simple table. And I'll show I'll skip around a little bit. I'll post a link to this actual example that anyone can run into the chat. But here's this example of the LDL values that we had looked at earlier. So kind of looking for the patient ID, just grabbing some values there and running that. So this is actually all running over the Cynthia data and BigQuery. But as you can imagine, like once we have this sort of flattened table, then it becomes a lot easier to join patient ID to their arbitrary results there, and then do an analysis in this space. And then
can we see the actual SQL that's being generated?
Yes, yeah. So it's yeah. So I can actually show you the SQL. So this is going to be yeah. So I can show you the full SQL here, and then I'll show. It is fairly complicated, but then I'll show you a simplified example, and we'll go into how it actually works. So what I can do here is, let me just add a cell. So in this case, so maybe I'll start with this simpler example to make the SQL a little bit easier to see. So we'll just do SQL. So I'll just, and actually it has some new lines in it. So you'll see it kind of like dealing with this complexity, and unfortunately it's not very well formatted by itself. So, but actually I have it. So that's the full SQL, but let me zoom in. I actually have an example on a slide here that kind of shows it. So if we were to zoom in like to one example, in this case, we basically, here's the postal code expression, address where type equals home. And then this is the generated SQL just for that expression. So that way you don't have to deal with all the poorly formatted noise you saw in the notebook.
It's still sharing the notebook.
Oh, my bad. Okay, here we go.
Okay.
Thanks for that. So anyway, so here's the just the one example of the postal code expression, and then the SQL that it generates from there. And so we can basically the kind of the way this works is that this looks complicated, but what we found is that we can basically just well, I don't want to say just, because there's some complexity to it for sure. If we build like the tree of the FHIR path expression, we can basically recursively walk that tree and translate each element of it to a part of this SQL statement. And then as we kind of bubble up, it all just emerge, the full query string emerges. So essentially, when we walk the tree, you see like this type equals home expression, and that just kind of that generates to this. We see it's wrapped in a where clause, and so we generate the where clause that goes around it. We see we're accessing the address there, so so that generates this substring, and then as we walk back up the recursion tree, it generates all this. So this is like kind of the sort of things that we see a lot. I will say that this particular query, this is specific to BigQuery's SQL syntax. We do have this running internally. I don't think it's public yet. We have it running over Apache Spark as well, and so we think it's the same pattern is portable. But the actual SQL translation, when you walk the FHIR path tree and translate it to these things, will be certainly be database or SQL dialect specific as we walk this stuff. So yeah, some complexity there as well. But yeah, so Evan raised his hand, so go ahead.
Yeah, I just wanted to mention this is like almost beat for beat what I'm hoping to do with this project, except instead of for FHIR path with CQL. And I can tell you that the way CQL is structured, you can skip steps 1 and 2 because Bryn's already done that for us. There's this intermediate language called Elm, which does that tree. And I prototyped a really simple knockup of a couple of simple CQL queries, basically doing steps 3 and 4. And it was simple. It took me like an hour to bang out, but the approach is almost exactly the same. So, you know, this is perfect. This is exactly what I want, essentially. So you guys are a breath away for solving this problem for me. If you can do it for FHIR path, you can do it for CQL.
That's great. Yeah, I definitely appreciate that. And it is exciting to yeah, I know that FHIR path, since FHIR path is a subset, it probably is a good step in that direction. So we haven't quite made that jump yet, but yeah, I think that makes a great deal of sense as well.
Yeah, that's amazing, Ryan. So, and do you have a nest in your view definition? Because we're still working with arrays, yes, and sometimes you want to. Do you have syntax nesting, something like, let's say we want all addresses to be expressed through this FHIR path, not only home addresses, but.
Yeah, so and so we can do that as well. So in this particular case, we're just grabbing the home address, and so in this model we might have so this might map to a column of just home addresses, and maybe we have different columns for, you know, a home address or a business address or that sort of thing. And so, but yeah, it definitely would support like propagating arrays up. Just the usage patterns that I show here and that I kind of work well, I think, in off-the-shelf business intelligence tools just work best with purely rectangular data without nested arrays. I mean, I can take, you know, a Tableau tool or a Looker tool to use the Google Cloud tool chain or whatever. I mean, there's many good tools out there that if you feed it a big rectangular table of data, it works really nicely with it. And so that's why we've kind of avoided arrays and nested structures. It's where, I mean, everything here will propagate those and it'll work fine. It just doesn't work quite. It's just not quite as friendly to some of the tool chain that some of our users use, which is why I've avoided in these examples.
And what about joins? So if I want to build view on top of different resources, do you expect like using resolve or?
Yeah, so I think that's a great discussion for the group. The stuff that in the example that I have, and like I'll share the full notebook publicly. The joins themselves is like the pattern we've taken is like basically creating a view for each use case and then doing joins on top of the views themselves. So we'll see the full example here of in this case where I create that sort of LDL, so the LDL values table. And so if I want to find, you know, the LDL values.
If you're back in your notebook, we're still seeing the slide.
Yeah. Okay. I'm not back in the notebook, but.
Oh, okay. Sorry.
Yeah. So, but yeah, appreciate that. Yeah. Thanks for the heads up. Better to be aware. better be safe. So anyway, yeah. So I think that the pattern that we've kind of done is that we'll create the views, which are basically one-to-one mapping of FHIR resource. So you take, you know, or maybe a one-to-many mapping. So I can have my person, I have my view of my home addresses and basic demographics, like say gender. And if I want to say get my LDL values and see the distribution per gender, I basically join my LDL value view and with my demographics view, and then do that all downstream. We find that that's very, very useful, because once you have those flattened tables, folks are pretty comfortable doing joins. I would, frankly, my inclination is to stay out of the join business entirely and leave that to the SQL engine on top of the views. They're really good at that, and I think it's a familiar flow once you have the rectangular tables. But if there's other opinions, we can certainly consider those.
Thank you, Josh.
Yeah, I mean, I wanted to ask about the joins too. So I think that mostly covers it. I will say that, like, looking at how nicely this kind of thing could run on top of SQL, it also occurs to me that there's a lot of folks who might want to run this before they've put their data in SQL as well. And that would be very plausible using this level of FHIR path query. I could imagine some features that would make that harder, but at this level, you could just do that in one pass.
Yeah, exactly. And I actually have it on, I'll go back to the notebook, I guess. I actually have it on my kind of to-do list in this thing, and hopefully I can find some time because basically this definition of the flattened views it really is not SQL's. I mean, it's completely decoupled from SQL. So we kind of describe the view, and then we have a runner that executes it. Right now, the only runner that we have available is the BigQuery runner. We have an Apache Spark runner that's in flight. But I can see, Josh, to your point, like a runner that just calls a FHIR service or just runs over NDJSON as is, converts that into a data frame. So I think we can fit those into different workloads. I think it'll be exciting to explore. But to be clear, my goal for this is not to like sort of, I'm not trying to sell this tool or anything. I just want to illustrate the pattern because I think alignment on this could be useful. So don't over-index on this specific approach.
That's amazing tool, but are you stick with your view definition, because we kind of discussed it to use logical model for something similar, or is it in stone? I mean, your language DSL to define view, or?
I mean, so this is just a Python library where you can kind of build these views in Python and then create it. It does not use a logical model at this point. I think that the relationship with logical model could be, I think that's something we could explore. I could see this where like the logical model that Brian was showing earlier, maybe each column is associated with a FHIR path expression and then run using this model. I could see other workloads. I mean, I found it convenient for some analysis just to create views on the fly, because, you know, if I can sit here, you know, and you know, just type in like, you know, any column that I want and just create the view, then that creates a much more dynamic interaction, whereas a logical model could make sense for a well-defined portable standard. So I think we need to explore that relationship. I saw a few hands go up. I'm not sure who was first, to be honest.
Ryan, I just had a real quick question. Just one thing I'm trying to visualize in this is, what does the FHIR look like in SQL initially, in the tables initially, before the JSON that, you know, your configuration runs and then transforms into a view?
Yeah, so and so I think this goes back into well, I'll say what it is now, and then I think there's a part of this group is figure out what we want it to be in the medium to long term. So what it is now is it's the original. I mean, there's that original sort of SQL on FHIR GitHub repository. You know, the V1 I mean, I think I wrote up most of that a few years ago, and it's been sort of sitting unchanged ever since. It exists in a couple. I mean, it exists like in BigQuery, and I think similar patterns exist in other cloud providers as well. So yeah, I'll ping a link to that. But yeah, it's basically. I mean, actually, maybe I can probably just bring it up here, or we can bring it to the chat. Let me get the link here. So here, I'll just copy this link to the chat. So basically, the baseline for this implementation uses basically what's described here, where it's basically maps you know, resources to specific fields. That said, part of the goal here is that these view definitions should be fully decoupled from the underlying representation. So, and I totally appreciate the fact that Nikolai, I think, really had emphasized earlier. There are likely databases in which we just want to store the FHIR as JSON and use the JSON logic to manipulate that. And so I think that the same runner could be, a different runner could be built that actually uses the JSON version. So actually, I thought I had an example. Oh, here we go. So right now it's like, we could, rather than translating it to the SQL queries like we saw in that example, we could translate it to say JSON path if you're running on a JSON engine there. So it's basically decoupled from the base underlying representation. But that I think so. This is sort of the part of like the level 0 and level 1 using Dan's terminology. In this case, we still need improvements to like sort of the base level 0 stuff.
Okay, thank you. That's exactly what I've been kind of curious about this entire time, is what that base level looks like and how that should look. And so it sounds like you're using the old SQL on FHIR. You could use JSON. You could use some kind of MapReduce that just takes in thousands or millions of JSON bundles from S3, which I've seen companies have. And there's all kinds of different ways you could transform the JSON FHIR into views. And your language is an intermediary representation that works on not those individual views, those base level 0 views, but on the FHIR profiles themselves.
Right. Yeah. The FHIR profiles, or just ad hoc, whatever. If I have a use case, I want to create a quick view of it and explore a notebook, just ad hoc. But yeah, that's absolutely the sort of the spirit of what we're trying to achieve in this pattern.
Okay. Thank you.
Awesome. Then.
Yeah. So I know we're coming up on time, so maybe this is something we want to start with next time if folks have to go. But I guess, Ryan, I was curious about like what edge cases have you run into where FHIR path doesn't work for flattenings you wanted to do, or it's hard, the SQL it's generating is, it's hard to generate clean SQL from it, I guess, because I really like this approach. And so I know you have some experience with it now. So I guess I'm curious, where are the challenges with it, or things you would ideally do differently if you weren't constraining yourself to FHIR path?
Yeah. So here's a few challenges that we kind of ran into. So make sure I'm sharing the right tab. So I think that, the biggest thing that we found that we need frequently that is not easily expressed in FHIR path, although it's doable, is like getting that raw ID for references. And so if you notice, I actually cheated a bit in this example. So that's the one thing I have that's not pure FHIR path, and that is basically a way to get the raw patient ID out of a reference. So I have a shorthand for that. That's not FHIR path. So that's an edge case there. It's a bit of a wart, but it's so common it may be worth justifying an exception for that. So I think that's one. The second item, the second edge case is one that I think you've already mentioned, is that dealing with variable date ranges it still adds that complexity in that space. So I think that Dan, I think that may be at least partially solvable if we have like some sort of common patterns for translating date ranges or date time types or date types into like certainty ranges. And so therefore, every time you see a FHIR path expression that accesses a date, it actually produces a certainty range there. So those are the two biggest things that I've seen in that space. Yeah. So yeah, I mentioned like in this, like the joinable reference IDs, those are the main things. And actually the one of these examples do have like member of support. That actually works quite nicely, but it does add some more. That I wasn't sure how far we want to go in this space, because like adding like value set checks and that sort of thing are super valuable. It does add complexity to the queries, and so finding like balance between complexity and expressiveness and ease of implementation is I think something that we need to follow up on.
Looks like if it will sit on top of 0 layer of transformation, things will be much easier. Yes, if we parse references and normalize time. So
yeah. If there's like that base 0, that level 0, which I love, like normalized time, parse references. Yeah, this implementation gets significantly easier. Absolutely agree with that. So yeah, I think that's so that's why I'm excited about both the level 0 and the higher level. But I think Donna has had her hand up for some time.
Yeah, and actually my question is along the same line of what Craig's question was, but I'm maybe asking it a little bit, simpler as far as the answer. And I apologize if it's a dumb question, but architecturally wise, before we've even flattened these views, would we be in agreement that you know, we're not generating this directly off of the FHIR server, that this is a parquet version of the FHIR downstream from like an analytic platform. And is the standard structure for that what I described as like your FHIR table and then the paths for that table? Would we be in agreement that that's kind of an industry standard that we're going toward before we start to flatten stuff?
I think that's probably the best pattern for many workloads. So I definitely agree that makes a great deal of sense. I mean, kind of like, yeah, get all the advantages of FHIR in a data warehouse capability, so you can get leverage all the power of that data warehouse. Strongly agree with that. I mean, the approach that we've taken in this example is like we are decoupled we have the definition of the view and then the runner. I think in most cases, the runner would run over a data warehouse and do exactly what you described. I think it may be convenient to have a runner that just, you know, loads NDJSON, just because if I just have a pile of NDJSON, maybe it's nice to use that against that. I don't have a data warehouse handy, but I think most like any large scale workload, I think will certainly want to do exactly what you outlined, Donna.
So like a data lake of batch structure, right? So if we have an open community of flattening views, that is the core structure that it would run on, right?
Yeah. Yes. Yeah.
Well, that's good news. I'm very happy about that.
We're gonna write SQL on FHIR IGs with a bunch of views. That's amazing, Ryan. Thank you. So we're a little bit out of time. Yeah. So, and I think we will start the next meeting from this very nice proposal. So yeah, let's work on this. I think that using like logical view to define this stuff in a similar way may be worth to explore.
Some people had mentioned joins. I may share another example that has lots of joins in it to kind of show how we're going in this from an unflattened view perspective. So if that helps.
That would be nice to explore, for example, like your use cases, how can be mapped to the flattened views, yes? So you're doing all this nesting, working with nested data structures, but can you imagine that you can prepare useful flattened views and then do the same much easier than you're doing with this common table expression?
Or the notebooks and that code that's complicated can just be publicly accessible because we now have a FHIR standard, right? And people can run whatever flattened views they want with that.
Yep, that's true.
This is wonderful.
Yeah, I definitely agree, and also it's like I do think, I mean, if there's users that are comfortable going directly to that sort of base 0, the full FHIR representation, like Donna had an example, I don't want to take that away from anyone, because like, I mean, there's if that works for your use case, then great. I think we've just found use cases where a flattened model can help a lot, and so we want to support that too.
Absolutely agree with that as well.
Yeah, details of the future standard. It's getting more it's materializing. Okay, thank you, Ryan.
Thanks everybody.
Yeah,
see you later.
Thanks.